Hello, good morning, and thank you for joining me in my shop. Today is March 4th. And if you've been watching my videos for some time, you might recognize this radio. This was in my shop about, I don't know, 8 weeks ago, something like that. Some time ago anyway, and I did all the usual maintenance type activities with it, and I got a fairly good result from the radio, except it hummed. And I pounded away on it for quite a few days trying to sort out the hum, and finally just set it aside because I didn't know what to do. And here it is now. I'm going to take another run at it. I'm optimistic, as most fools are at the start of things like this. So I think the first thing we're going to do, we're going to play the radio and assess the hum. And see if, maybe it's not as bad as I thought. I could have got a little bit, what would the word be, hypersensitive to it, maybe when I was working on it. So let's start with that right away. Plug them in. Now I have no boosting antenna here, so it's just going to be its own antenna doing the job. We'll see how well that works. Turn the power on, that would help too. There we go. So this is a very classic radio. Very desirable radio by collectors, especially the plastic version. This is a wooden version. There's a plastic version that people really want this. Looks to me like it's shaped after a bank. That's the impression I get when I look at this radio. Other radios are shaped after cars. Okay, here we come. Well, it is humming. I'm not even sure you can hear it. My furnace is running right now, so there's some noise in the background. Oh. Okay, so here are the difference between these two hums. First of all, this hum, which I'm hoping you can hear, is very low. It's very mellow, kind of pleasant, low hum. When I turn the volume up, that hum doesn't change. What happens is another hum is introduced. This is the one I was chasing. Two hums in one. Something a little loose in there too. Ooh, what was that? That. Hello, anybody home? So I'm grabbing the antenna here. So this antenna on its own, wow, it's not doing well at all. I mean, if I do this, the receiver's ready. It's just getting nothing from this antenna. And look at this thing here. Let's fiddle with it. Nothing to do with the hum. Doesn't seem to do anything, does it? I was wondering if it was shorted out from dirt, but I don't think so. Oh my. But just grabbing this wire, this hardly makes a difference. There's something definitely wrong with the antenna here. Okay, that's enough. We're going to bring it out and put the chassis on the bench and get to work on it. Got a couple things to look at. So I took the radio out of the cabinet, obviously, and when I looked at the antenna, I can go, oh, how is it? It's really complicated. Look at that. And there's a pair of wires here and a pair of wires here, and then a couple lights came on in my head, which apparently were not on earlier. One light is, well, if you're doing this and it's going shh, 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 but you're doing this and it's not doing anything, it's because you're tuned to the shortwave band. That's why. So we're going to try that again. So I think this was just switched to shortwave, and that's the only reason that was happening. And that's why it's got two pairs of wires. It's got one pair from the loop antenna. That's also why this didn't make any difference when I fiddled with it. There we are. Lights are on now. Let's try the radio again. Out of the cabinet now, we won't hear the hum nearly as well, especially the lower one, the smooth one. We won't hear that. And I think this is in the same position now. Okay, I think it's warmed up. There's a small hum there. This is the volume dependent hum, which means it's got to be sourced in the audio circuits. I think that's what that means. No, maybe not. Okay, what do we get? We get nothing. Okay, other band. Oh yeah. There we go. So out of the cabinet, hey, this sounds really good. That other sound, you have to raise the volume up quite high. At this point, the radio's amplifying tiny sounds and making them quite loud. If I were to flip this back to broadcast, I'd probably blow myself out the door of my shop here with volume. So if we're not going to advance the volume far enough to hear the other hum. Maybe this is how I was driving myself nuts here with it. Because you're only going to go up this high. It's very good reception. No boost. It's all on its own. And now, not much different. It's quieter. Come right out. So at the low end of the frequency right now, let's go to the other end. Now, I don't think there's anything up here to pick up. Ooh, what's that? Something there. I don't know if that's a station or just something. There is one AM station to get up there, 1580 I think it is, 1480. Not gonna get it. Okay, let's pick a what we think is a faraway noise. What would that be? Too low frequency. Let's go up again. No reason to think this is really a faraway sound, but let's use that. Quieter. It's quite distinctly quieter. Quieter all the time. Okay, that's good. Let's try 860 right around here. Hello. It's usually stronger in most radios. So what I'm noticing that's kind of weird is I have the antenna in this plane. Same plane. Where's the reception? So my imagination, it seems a lot louder this way. Going down. Well, I don't understand this being different from that. Is the speaker louder in the back? Does it project more backwards? No. No way. Okay, what about the hums? Let's go on shortwave here. I'm going to have to put a better antenna on to do the shortwave side of it. So, coffee break time here for sure. Here's something a little bit interesting. So the radio is just playing on AM radio. I'm getting ready to switch to shortwave and see what's happening there. So you can hear a station a little bit. This is the cable that's bringing the signal in. It's hooked up to nothing right now. I'm just getting ready to hook it up. But watch this. I'm going to just move the camera a bit here. What do you think of that? So what I'm showing is that I can put radio frequency energy into my body, and then I can take the energy in my body and stick it into this antenna. I can bridge. I'm just grabbing the outside of this too. Okay. I guess I'm somebody special. I guess, and you know, in the old days, you know what that word meant, special. Okay, we're going to hook this up. Better on AM. Swooshy sounds. No swooshy. Okay, I'm just making observations, no idea what to think of them. So we're right in the middle here with the pointer. So we're right around, this is 8 megahertz, that's 10 megahertz there. Should probably find 9.3, maybe. Coming up on 9 actually just now, according to this. It depends how well I did the alignment on here. Hey, come on down here. Nope. I expected to pick up 9.3 here, but maybe there's nothing there. There's 10. Soon, we're gonna pick something up soon. We're up here now. Something soon. Come on. Obviously. Ooh. Oh, that's much better. Tune it back. Wow. So I think with this radio, if you were to use an outdoor antenna, which you need for shortwave, then having a ground rod type grounding would be quite advantageous, I think, in the signal strength. That's what this is doing basically. So I'm feeding a signal in, instead of just letting this wire poke at the antenna, poke at the radio rather. It's poking at the radio, and the radio's doing this. Most of the poke is being absorbed in the radio. If you believe this explanation. But when you hook this up, now you're poking like this, and it's not possible for the radio to kind of, absorb in the signal. Like, how can I explain this? I don't know if this is even a valid analogy, but say you have a stick here, and you want to apply a certain pressure on it. So you apply the pressure, but the stick bends back. So it's hard to apply the pressure on the stick because it keeps bending. But if you can make the bottom rigid enough so there's no bend, you can put a lot more pressure on the stick. And so, this is the ground connection, and this is the signal coming in. I don't know if that was... And, stuff comes to my head and it comes out of my mouth. And afterwards I think about it. What can I tell you? So, the radio's working good. So let's just focus on this hum now. So we have a volume rated 0. The signal's so strong, it's still coming out. So, the radio's out of the cabinet. And I know what happens if we put it in the cabinet and the hum is much more pronounced than it is now. How can I imitate that? What could I do here that I could do and undo that would imitate it going in and out of the cabinet? I need a big board with a hole in it about this big. Yeah, a board I can bring up with something I can bring up with a big hole in it. Yeah, I got anything like that at all in my house? Okay, got an idea. Got this box here, and I'm just going to cut a hole roughly where the speaker is. Maybe where the dials come out. It's almost like a fake cabinet in a way. And yeah, that's what I'll do. I'll turn this into a test cabinet, and we'll just see what kind of influence it has on the hum, the audibility of the hum. Okay, here's how this is going. I got to figure out where the speaker is now. The box is almost exactly right. What's keeping it from going forward here? draw a circle here. Okay, that's as much as I can get. Should do the trick though. There we are. Now I finish the circle. Where'd my pen go? What did I do with it? Here it is. Must come right down like this. The hole doesn't have to be perfect. That doesn't have to. It has to be a lot smaller than this. It has to be on the inside of this. And cut this hole out here. And always cut it bigger. Can't cut it smaller. Okay, that's the piece I'm gonna cut out there. And we'll have our test box. See if we can get anywhere with that. Great. Okay, so the idea here is to get this box on and off very quickly so we can hear the difference. If we do it too slow, we'll never hear the difference. Let me get some elevators here. Is I can't do it because of this. I don't know. I don't think this is going to work very well. Front-loaded radio here. What if I'm holding the radio? I don't like that idea offhand. It's really awkward to hold this. Do this thing. Easier. That would have been a better idea. That would have been a better idea to go above the knobs and just cover the speaker. So the hole I've cut here now is, man, I might even do the trick right there. The idea is, pull this away, don't hear the hum. Put it on, hum is, you can hear the hum. That's the idea. This is probably enough to prove it. Yeah, well, I got this. Let's try it. Let's try it. Okay, radio on. This was a mistake doing that. We just need something with a hole in it, really. Just a flash of it. So it's got a big gap right here, which is counterproductive. But let's see what we get with this. Yeah. Okay, kind of doubtful this is going to work. Minimum volume. Let me take the this off. So all we hear now is the hum. I can hear it. You probably can't. Oh yeah, that worked. That certainly worked for me. We'll try that again. I'll be quiet. Listen to the hum. If you can hear it, I can always hang a microphone closer, but. Oh yeah, there's no question that boosted it, and I just still have this huge gap here. So what you're trying to do with this box, what I'm trying to do anyway, is I'm trying to block the air from leaking around the edge of the speaker. As a speaker pushes forward, some of the air will spill across and come around to the back. Why is it going around to the back? Because the back is sucking. this is pushing, the back is pulling, and the air will just do this. And what happens is the lower frequencies just disappear here. Higher frequencies can't make it around the bend here very, very quickly, and I guess maybe they're projected more, maybe, I'm not sure of that. So this effect is about loss of bass or the creation of bass. I got a loss of bass, I guess is the right way to put it. If you have leaks, like large holes in the paper of the cone, the same sort of thing can happen. I bet you that's my dentist calling. Okay, let's do a little experimenting. Now this microphone is normally hanging up above my head along with another one. This is usually the left channel. The other one's the right channel. So what I'm going to do, or it could be the other way around. I mean, you know, your headphones might be the other way around there. So that's my right ear for me. That's my left ear. So I'm going to turn this. I'm going to turn off the other microphone here. Okay. Now we just have this one, and I'm going to put this in the center. There we are. Now, is this the radio you're hearing? Let me turn it off. Okay, so that gives you a pretty clear idea of the sound coming out of here. This is laying on the bench, and so it's picking up any bench sounds. If I pick it up, what happens? A little bit of a change. Not much. Now, oh, there's some electrical pickup here too. I'm not sure. Can that happen? Put a directional microphone into the top. Okay, so I'm wondering if there's an electrical interaction occurring, but I don't think there is. Now, I'd rather have this held here. Maybe I'm going to have to hold it. Can I hold it? Yeah, I can hold it. As long as I'm very still. Okay. Wait a second here. Okay, that's better. Now, any difference in the microphone? Those are much louder. That's how it sounds to me. I can flip this away quicker than I can put it on. Here we go. Now you might think, well, you know, the box is projecting the sound forward. And maybe it is doing that a little bit. But I think really what's happening is I'm blocking the low frequency short circuit of my unbaffled speaker. I wish the hole was more accurate. A little bit of a better test. Okay. Not sure what that proved exactly. Wow, I speak right into this microphone. Doesn't that sound different? Yeah, let's do that experiment here. So normally this is hanging up above here. Let me go up. I just hang it in the rafters there, so to speak. So here, get the camera on here. A little experiment here. So that's aimed at me, and then this is normally how I'm talking into it, like this, as opposed to this. Actually, you know, it sounds better this way, doesn't it? Don't you think? It sounds more roomy. This sounds like I'm right up against it. I'm a foot away from the microphone here. Very directional. I'll have to check my other one there too. Yeah, let's do that. While we're messing around here, switch microphones. Okay, we're on the other microphone. I'll put it in the middle. Okay, now that's this one way up here. What am I trying to do? I'm going to try to talk into it. Okay, so I'm talking to the side, and now I'm talking straight into it. Oh yeah, you can hear a difference with this one too, if I talk. But it sounds better actually. This sounds better straight into it. It sounds fine either way. Actually, it sounds a little more canned this way. A little more better fidelity this way. The other one's the other way around. So it seemed. Okay, now I have these fantastic flexible techniques for hanging this stuff up. I got another microphone. Why don't we try another one while I'm playing microphones here? We'll try another one. Try to get that back. Okay, so that's where that's normally hanging. Let me reset all these microphones now. So everybody's back on. Okay, that's back to stereo. Yeah. Okay, totally different microphone. I have another one. Let's just keep experimenting here. Nothing to do with the radio, but so this one here, I'm not using it. Let's flip to that one. I'm not even sure it's. Let's see if it's working. That's not working. Why would that be? Because it's not quite plugged in over here. Well, let's try again. There we go. Okay, now I'm talking in this microphone. So the idea of this one, I'm not using it. I only got one channel happening here. How come only one channel? One channel. Come on, one channel. This one's just a hiss. Yeah, that's why I'm not using this microphone. Okay, there we go. Now we're in stereo. So this is a stereo. This microphone here is a stereo one. And the idea is I'd be speaking into it when I'm gawking at my computer screen. So what would that sound like? So I would be up like this, talking away. Sounds fine. A little boomy. Other mics, if they're on at the same time, it just sounds like that. And if I take them off, there we go. Microphone experiments done. Okay. Sorry about that, but I seize the opportunity. You know. Now. So what good is this demonstration here? Well, it reassures me what I believe about what goes on with speakers and why you can't hear a hum quite often when it's on your bench and you put it in the cabinet and it's humming away, and a cheap way to just double check it before you do that. If I had a better circle, a better piece of cardboard. Well, time to try to figure out why it's humming now. Because I think what I've done is I've assessed the hum as being important enough that we got to do something about it. Go back here. I don't know, did I finish zooming around the shortwave band? Let's just do a little bit of that. Yeah, you can hear that hum. That, like maybe 120 hertz hum.
Occupiers continue to drive our society into socialism and anarchy. The message to bring America home grows more crucial by the day. Beth Ann brings that message with contagious passion wherever she speaks. Schedule Beth Ann to speak to your group today by calling 5737-166.
You wonder where Mike Lindell went? He's on shortwave. He's in the shortwaves. He's back to just selling his pillows. Let me just tighten this up a little bit. So the whole time I'm listening to this, and I'm sure you two can hear the hum. It's always there.
And like all of Mike's products, they come with a 60-day money-back guarantee and a 10-year warranty. Right now, you can get your very...
How did that guy survive? How did he stay in business? Maybe there's a lot of money in pillows. Okay, that music could be copyrighted, so I just have to break it a bit.
You have lots to get to cover. Her spam burger, because she's fake. Spam isn't real ham. I know some of you probably like it. I don't like spam. I don't like the texture of it. Now, treat meat is another one that's probably not really ham, but I like that one. But
the knob here.
Burger is what I call her because she campaigned as a moderate, but she is totally not a moderate. And the reason I made the smart aleck remark about rape is because Spam Burger wants to make rape a misdemeanor instead of a felony. They are catering
Sharia law.
That's where the Democrats are, my friends. So on February 4th, Governor Spamberger signed an executive order terminating all state-level 287G agreements between...
Oh, okay, man. Woman. Where? So the radio's working quite well. It's just this hum. So it's got a good antenna on it right now too. Okay, we must. What? What's this? Is this the hum we've been hearing? No, no. Well, a lot of stations. You can hear them as I go past them. That's FT8 from Ham Radio. Probably Radio Marty.
Bienvenido, William.
Probably Radio Marty again.
Rape and murder.
We're listening to that. Rape and murder. Must be American radio. Probably Radio Marty again. So that's a single sideband ham radio. Oh no, it isn't. No, this is air traffic control over the Atlantic Ocean. We probably won't be able to understand what's being said. Let's see. So those tones are called SeaCal tones. Doot, doot. And in the airplanes flying over the Atlantic, that'll trigger one of them. I guess set off a bong so the pilot or the radio guy will pay attention to what's coming next. And my little... There we are. But we won't be able to understand it. So that is one of the things that you can pick up on shortwave radio, and SDR makes it really possible to do it, because you can tune in the area, let's say 8 megahertz area, where these signals are. You can look on the internet and see exactly what frequencies are being used too. But then you can just look at your waterfall display and you'll see momentary transmissions. They come up, of course, as a line going down the waterfall, and then you can investigate those lines. And sometimes you'll come across air traffic control or other things. SDR is wonderful for doing these kinds of on and off transmissions. And a regular radio like this, if the transmitter's not transmitting, you'll tune by. You never knew it was there. How would you ever know it's there? But with an SDR, you can look on the waterfall display and see all this stuff. It's fantastic, just fantastic. Like a dream come true for someone my age who likes to listen to shortwave. Yeah. So now this hum, this is probably a received hum. Hang on, I can take it off the antenna. We better take this. Hang on, or you blow our ears off. It seems like a certain range in around 10 megahertz there. Okay, that's enough of that fooling around there. Enough Jim foolery. Okay, the hum. So I previously investigated this to a large degree and could not find any reason why this radio is humming. But the one thing I did not do is I did not do a tube swap through all the tubes. So I think that's what I'm going to try. I'm going to try to swap every tube one at a time and see if it doesn't quell the hum with one of the tubes, because a tube can cause a hum. Think about this now. The hum is controlled by the volume control. Okay, we'll think about that. I'll think about that. Okay, I've got lots of the tubes, these tubes that go in the 5-tube radios. I have lots of them, 12SA7. That's the first one we're going to try. And I better not mix up the originals, which I will put over here, with any test ones I put in. 12SA7. So you see this one's not numbered, but you see this one is numbered. So at some point, and this happens with all collections, I think, I kind of went through here, tested all the tubes, but then later I got more tubes. So the tested tubes are numbered. These are ice cold. They just come out of my garage. Is that a good thing to take it from ice cold? Probably not, you know. Probably let this warm up a little bit. And then we're going to try it and see if the hum is any different. And if you're wagering on this one, I wouldn't wager too much money on this. Okay. Of course, the inside of the tube is still very cold, I'm sure. Let's just give it a little shot here. We'll give it a little shot. Shot! Okay. Now, that was just to put a little heat into that tube. I've never seen a operating temperature range for vacuum tubes. Obviously, they can work really hot. What happens when you have them really cold? I mean, obviously, there's enough mechanical expansion and stuff. Maybe it would cause a problem. Okay, I have lots of them, so let's go ahead with this. If this, I should somehow blow up this tube. Mr. Radio, do you hum? I hung the microphone back up. Maybe I did that a little prematurely, but I still have my own ears on the side of my head. I didn't put those away. Might be interesting from a performance point of view too, as we swap these tubes around. You might notice performance changes. Okay, so I hear a hum. I hear the low, mellow hum. I gotta turn this thing way up. That's not the way the other tube was it? Oh, I don't have the antenna connected. Yeah, that's no doubt part of the picture here. So that changes the hum a little bit. Sounds the same to me. Volume controlled hum. Would it be worse? Okay. You're listening to it. When I pull this tube out, it cuts the whole radio off. Put this one in. This is the original. It's interesting, I pulled this tube out and the hum didn't go away. So for a while, the tubes remain hot and they continue operating even with one tube pulled out. So this is just warmed up now. Yeah, I think this is a better tube than this one. Okay, so what did we find out there? We found out that I have another testing opportunity. That's to yank a tube out. Yank a tube out. Okay, so the tube comes out and immediately listen. Does the hum just drop right off at that moment? Here we go. Tube's coming out. The answer would be no. Look, it's still going. Wait a minute. Okay, just took a while for the thing really hung on, didn't it? Let me turn the power off while I stick this back in. Okay, power back on. Next one to yank out. This one here. If the hum disappears, you have to sit and think about it for quite a while, just what this is really proving. It's not clear what this would prove. Where's the other hum? I hear the low hum. Did that do it? So we still have this low, what would probably be a power supply hum. This has got a, it's got a fuel coil speaker. Oh, that's right. I remember thinking maybe there's something wrong with the humbucking system in the speaker. There's a humbucking coil in here that is supposed to work against the hum being generated by the fuel coil. It's built right into the speaker. It's a fixed thing inside the speaker, and if something has gone wrong with that, it won't balance out the hum properly. But this other hum, where'd it go? Is it there? You know what? I got too much signal from the antenna, so let's take it off. Wow, it's still there. Hard to judge, if it's gone low. I was tuning in shortwave stations and finding the hum was enough that it was there with the weaker stations. I don't know. That's really good. Could it be just unplugging and plugging in the tube did the trick? If that's the case, let's do another tube. Okay, so I'm going to pull out, this is the detector tube here. Yank it out. So, listening. Here. So the low hum disappeared. The other one seemed to stay for a bit. The low hum disappeared. Let's put a different one in for this. Now this has come out of, this is one of my tubes here. 12 SQ7. We're just going to grab another 12. What did I do with them? Here they are. Ooh, SQ7. SQ7. Do I have one just laying around by some wild chance? Yes, I do. Here's one. Let's put it in. Power off. And on. Now, I just grabbed that tube off my bench. I think it came out of that radio. And it's the original one. This is the replacement. Could be that tube is shot. I'm not remembering. Let's see. I think it was really weak, if I remember right. No antenna on it right now. So hum level about the same. Let's put an antenna on it and see how it's working. Ooh, it really gets hummy when I put this on. The radio is not plugged into a regular outlet here. It's plugged into an isolation transformer. So applying this ground changes the situation fairly dramatically. You plug this in a regular outlet. You can see I've marked one side here. This is the the ground side, and you can't see it. There's a mark I put on here to try to put that in the wide part of the outlet. Plug it in a regular outlet. You could try that. We should try that. So, weren't we listening to a station here? Maybe not. I think I fooled around with it. Okay, let's try that. We're going to plug this right into the wall. I'm going to take that off. Before we do this. Okay, here we go. Into the wall. Not really the wall. Oops. Okay. It's in. Now, just an abundance of safety here. We're, trying to keep the level of personal embarrassment as low as possible. Six big volts. Same? No, nothing. That's interesting. Oh, look what I'm doing. It's not interesting. Same thing, yeah. 6 volts. Let's do the ground one first then. Wow. There you go. don't hook this up to one of those kinds of antennas. I don't really have an alternate antenna here. Maybe just a piece of wire. I'm the antenna. Hey, I'm pretty good. My directional. No. I should try dish. Okay, I'm having fun here, but what am I really doing? Really getting nowhere. Once again, with this radio, I'm getting nowhere. Well, we could try the rectifier tube, and we could try the output tube. It can't be sourced at the output tube, because when I pull out an earlier tube, it all kind of disappeared. When I pull this tube out, the rectifier tube, I think the hum source, the hum source did disappear. That wouldn't be a valid test. Would it? It's hot. Went pretty quiet, didn't it? I mean, a B plus disappears, everything disappears. So I think that was kind of somewhat of an invalid thing to do. Let's put it back in. We'll try this guy next. I'm going to go back to the control supply here. If I pull this tube out, you know, it's goodbye to the power to the speaker. So can it possibly hum? The field coil might generate a hum. Okay, there it is. That's a nice low, warm hum. That other one seems to have disappeared. Hey, I'm picking this up with no antenna. So what's happening here, the reason the radio can receive better if I touch the chassis is because the little short antenna wire here and whatever else is actually picking up the signal has to work into something. Something with some capacity, some charge capacity. It can't push into nothingness, like it has to go into something. So there's a certain amount of metal here, but if I touch this, I increase the amount of stuff. The I don't know, the capacity, I guess that's the right word, the capacity of the other side of the antenna. So you have the antenna, then you have the antenna coil, then you have the other side, which is what we're talking about, the other side. That's how I interpret that. You know, I am standing on a floor here. Maybe there's some capacity to the floor. You build up even more of a counterpoise. I don't think that's quite the right word for it, but maybe sort of like that. Little tiny piece of wire in my basement. I would touch the chassis for fun, but I'm not going to do that because I think I'm raising the possibility of me getting a shock, so I'm not going to do that. But what I think would happen is if I'm supplying the antenna and then I touch the chassis, I would drain some of the signal out of me. There won't be as much difference in the radio to operate. I will have grounded away my own signal into the chassis, so to speak, or the B minus, or whatever you want to look at it. B minus through the capacitor. Well, I don't know. I'm just having fun here. Let us do the reality check now. The hum reality check. My furnace just came on, so we have that hum going too. So volume down. Frankly, I'd be having trouble hearing it over my furnace. Well, that boosts it, even with this much of a gap. Very much so. I gotta make a better experimental cardboard thing. Well, where am I at here? I'm at radio still humming. The hum is on the fringe of being annoying or not annoying. I should put it back in the cabinet and do a reality check again. Did I change all the tubes? Have I done all that? Did not do the output tube. Did not change out the output tube. Yeah, it's hot. It's a hot one. What's this? 50L6. Okay, we'll try that. Well, I should really finish when I start, shouldn't I? I have trouble with that sometimes. Okay, let's see if we can find a... I got a box of them. So I keep all the L6 tubes in this container. It could be 35L6, 50L6, 6L6. I think I have somewhere else where I put those. The 6L6 is a very special tube. It's very different from all these other ones. So 14. 50L6. Okay, again, ice cold. Okay, I'm going to give this a couple minutes to warm up here before we try it. Okay, let's give this a try. This is on. So there's a low hum. I'd say there's more. I'd say there's more hum there. I'm not sure what this is going to prove, but Lots of hum. Because I changed that? Volume's not as much. I think it's got less volume. Oh, no antenna. That would be the reason. That would be the reason. Same hum effect doing this. Why so distorted?
Autorizado a las pequeñas y medianas empresas, ni pymes, abrir y gestionar residencias para adultos mayores y personas en situación de discapacidad. Publicado en la Gaceta Oficial, llega en un contexto en el que el 25.7% de la población cubana tiene 60 años o más y el envejecimiento avanza aceleradamente. Elaine Acosta, directora del Observatorio de Envejecimiento, Cuidados y Derechos, Cuido 60, dijo a Martín Noticias que la decisión era algo que había que tomar hace mucho tiempo, dado que la oferta pública de cuidados la calidad. Hasta ahora,
Where's the pointer here? There it is. So we're at 13, just below 13 megahertz according to the dial. The hum is changing its nature. I'm going to tune down rapidly here. Just listen to the hum. Pointer's right here. Just a spot in here where it picks up a hum. Right, did that before. Listen to the hum here. So there's a chance this hum is coming. This hum is coming from the studio where they're transmitting this. I've heard this before, where the hum is coming from the studio, because that's really distinct. It's fading in and out with the signal. Ooh, disappeared there, but the sound didn't. I'm not sure what to make of that. There are hums that can become more pronounced, maybe because of the ABC variation. I'm not sure about that, but I thought that was in the transmitted signal. I'm not sure now. Let's pick up another one here. So the hum come right back. Is that the same one? That's the same guy. Let's get another.
Hi there, and thank you so much for listening. This is Summer. I'm owner and operator here at...
La Universidad y la Resiliencia apareció el pasado 2 de febrero.
Where's the hum?
Según explicó, tras la primera publicación, la rectoría decidió inicialmente que no podía continuar impartiendo clases.
Next
Sin
station.
embargo,
We'd be happy to assist you with any of your health and wellness needs, whether you're currently combating serious disease and infection like...
Su permanencia. Ese respaldo permitió que Tablada continuara impartiendo clases durante el semestre pasado.
Maybe it's an interfering adjacent station, and the radio's ABC is going up and down, and this is causing it to hear more or less of the adjacent interfering signal. I'm making that up because I don't hear any hum in this signal. Where'd he go?
Los pastures here
Now I hear it. Where do you go? I thought there was another strong. We need a strong. Here's a strong one.
Posteriormente que el caso está siendo evaluado. Tras hacerse pública la decisión, la facultad aparentemente le habrían pedido que evite hacer comentarios sobre el tema mientras se revisa la situación.
It's just the inherent hum of the radio there. Well, maybe a little more. And then we go to that other station. Where? Where'd you go? We lost him.
Thanks a lot.
That one.
Since the beginning of the United States, kings have sought it. Nations have fought for it. It has been traded, borrowed, purchased,
Ooh,
and stolen.
what is it?
There is a reason for it. To secure the blessings of liberty to ourselves and our posterity. Invest with the security of gold and silver. Call Discount Gold and Silver Trading at 1-800-375.
Buy our gold because liberty.
375-4188.
Well, so I don't know what's with this hum. Let's go up here. No, find another station. Let's go right to the end. Okay, we're at the end here. Come back. There we are. Big hum. That's here.
En Cuba.
Estas y otras informaciones al regreso
No
de la
hum.
pausa.
En breve regresamos con más de Martín Noticias en Radio Martín.
No doubt what that was. Hum.
And folks, again, talk to Mike Kindred, discussing Catholicism. What he was involved in for 35 years, about half the site, before he saw the truth of the matter. You know what? We're going to tell you how to get a copy of the book. That was just to give it up.
It's hard to believe they're transmitting that level of hum in their signal. That's outrageous. No hum, nice and clear. Radio Marti. Commercial-free entertainment radio for Cubans, paid for by the Americans. Here it is again. The Americans used to, in the 50s, fly 3 airplanes continuously around the island of Cuba, broadcasting television signals into Cuba. And they kept that up for a long, long time. They always had 3 airplanes flying around Cuba, pummeling it with the American message. Of course, in Canada, they didn't have to fly airplanes. It just came right over. No hum. Having a lot of fun here with this radio today. I just wanted to come in and finish off that video, but this video. But and just in case you're curious, it's 1:30 in the afternoon here. Ooh, what's that? No hum in the signal. hum slowly getting louder in the radio here, and then going down like there's a. No, it could be some powerful source of interference here in my house. I'm sure there is. It could be causing that broadband style interference. Okay, enough of that. I can do that all day, whether or not. Bottom line is, I don't think I can do anything about the existing hum in this radio. I can't sort it out. I could attribute it to the possibility that the speaker humbucking coil is bucked up somehow, and there's something about that that's just not working right. It doesn't matter what you do to the rest of the radio if because that's just inherent right in the speaker itself. There's just nothing you could do to overcome it. The hum it's picking up with certain stations. There is a characteristic in radios where there be a hum that only appears when you're listening to a station. That is a characteristic of a certain kind of problem. I don't think that's what's going on here. I'm not sure what was going on there. That particular stations have hums, or come in with hums. I don't know. Who knows? But anyway, the reception was pretty good. I had a lot of fun with it there. Good antenna. It just needed good antenna to do that kind of thing. So, well, thanks a lot for watching. I'm going to put it back in its case, and it's done. And then I got to think of something good to bring in here tomorrow. What could that be? Thanks a lot for watching, and see you.